We are all born scientists. We come into the world filled with curiosity, wondering how things work and why. From the minute we first begin exploring the world, we are busy doing science, observing, testing, trying to figure out what's going on. As they struggle to solve the problems their environment poses, babies try everything. Touching, looking, listening, even tasting. Grown-up scientists take a more organized approach, one that makes it easier for them to answer their questions about the world around them. They call this approach the scientific method. One such scientist is chemist Betsy Rasmussen.
I'm very curious about nature. I'm a fairly logical person, and I like to find out answers. But I think the basic reason is that it's fun. As a small child, I remember wondering why earthworms wiggled. I remember wondering how fireflies made lights. And I was much more interested in why things happened and why animals did things. And so
Dr. Rasmussen's curiosity led her to a very big animal subject, the Asian elephant. These large mammals are dying out in the wild. Dr. Rasmussen works with elephants in captivity, hoping to learn something that may help the species survive.
All right.
The scientific method begins with observation, noticing something about the world around you. Dr. Rasmussen noticed that male elephants seemed interested in places where females had urinated. Sometimes, she observed, the males behaved in a very specific way.
the Asian bull elephant puts his very trunk-tip finger in a spot of wet urine. He curls it around to where he places it precisely on the roof of his mouth, where there are two openings. These openings lead to the vomer nasal organ. This vomer nasal organ is a second nose and can tell the bull elephant what compounds it is in the urine.
The chemist's observation led her to make an educated guess about why the bull elephants behave as they do. Scientists call this kind of guess a hypothesis, a statement that suggests or predicts an answer to a question. Dr. Rasmussen guessed that the bulls were responding to some chemical in the cow's urine, perhaps a signal that the cow was ready to mate. Such a chemical could be used to encourage elephants in zoos to mate, or to lure wild elephants away from villages where people might kill them.
You've done this kind of
The chemist's next step was to try to find out if her hypothesis was right. Like most scientists, Dr. Rasmussen started by going to the library to see what other scientists had already learned about elephants and their behavior.
You only found 7 with that combination, because there are probably a limited number that the chemicals have been identified.
Why don't I go back
All
in?
science builds on the discoveries of other, earlier researchers.
We're beginning the process of dialogue.
Each scientist hopes to add something new to that knowledge, something that will help fill in the blank spots in our understanding of the
The first
world.
term we're going to enter is pheromones. And as we remember, those were the chemical signals that animals gave out back and forth to members of the same species.
This is a form that takes less paper.
And there turned up the ones on the pig.
Empty out, Bill.
Next, Dr. Rasmussen decided to try to find out exactly what chemical or combination of chemicals in the cow elephant's urine was making the males react. That meant devising an experiment, a way to test her hypothesis by seeing how the elephant responded to different chemicals she could separate out of the female's urine. Experiments are the proving ground of science. They are carefully controlled tests, often repeated over and over, to prove a hypothesis right or wrong. Dr. Rasmussen decided to extract different chemicals from the cow elephant's urine, then see how the bulls reacted to each substance.
The urine is a mixture of 1 million different compounds. Well, let's use the analogy of a haystack, because that's kind of a good one. You've all seen a bale of hay or a haystack. Well, let's pretend that in that bale of hay or haystack, there are needles and pins of various sizes. There's some thumbtacks, there's some needles, there's some safety pins, there's even a few hairpins, and then there's all kinds of pins we don't know what they look like. And one of those pins is the one that's the most effective sticker. It'll give you the biggest punch into your skin if you happen to hit it. And that's what the bull elephant's looking for. He's looking for the molecule or the chemical compound that's the one that means something to him. And that's what we're trying to get out of urine.
Once she has extracted a particular chemical from the urine, it's time to test it on the elephants. The chemist fills several cups with plain water. Most of these cups will be used as controls to make sure the elephant isn't just reacting to water. But into one cup, she adds a small amount of the chemical she has extracted from the cow elephant's urine. The zookeepers wash down the elephant yard to get rid of old smells that might confuse the results. Then Dr. Rasmussen pours her numbered samples on the yard's concrete floor. She pours the samples far enough apart so she can keep track of exactly where she put the chemical she is testing. The bull elephant is released into the yard, and Dr. Rasmussen watches from a distance to see what he will do. The chemist will write down each response the elephant makes. An important part of any experiment is collecting data, measurements, and other facts that record exactly what is happening. After each step of the experiment, the chemist stops to think about what she has observed before she goes on to the next step. Her thoughts help her draw conclusions, answers to the questions she began with. It can take a long time to find the answers to scientific questions. After more than 10 years of working with elephants, Dr. Rasmussen believes she is on the right track. Soon, she hopes, she will discover that needle in the haystack, the chemical that helps bring bull and cow elephants together. No matter what they study, all scientists use the same basic method. They observe a problem, hypothesize an answer, test the hypothesis with experiments, and draw conclusions.